Okay, good morning everyone. Today we are going to discuss another topic in the list interface of a collection framework. It is a linked list and the stack. Normally, in the previous session we are discussing the collection framework introduction. That means what are the types we have in the collection framework, and we are discussing about the list interface. Right? Normally, iterable is the main parent to the all. From the iterable, the collection framework class will be inherited. From the collection framework, your list interface will be inherited. And from the list interface, it has the different types. We are discussing the array list, right? And we have the another type of vector. Array list and vector both are the same. What are the methods have the array list? Those all can be have the vector also. But the difference between the array list and the vector is in the size allocation. Normally, with a default capacity, suppose when you are creating an array list, you are not adding any elements to that array list. Default capacity for that list is 10 elements. Okay, default size. Suppose if I created an array list, then the default capacity is 10. I am talking about the capacity, not the size. Capacity means it can be initially hold the 10 elements, right? If I finished with storing of the 10 elements, then it again increases with the new size. Array list, how it will be increases? Suppose initially it has the 10, right? Now the size will becomes as 15. That means initial capacity plus initial by 2. Next size can becomes 23. Okay, and next size can becomes 30, like this. In that manner, it will be increases the size. But vector, what will be happen is, in the vector, suppose the first size is 10, then next it becomes 20. Okay, and after that it will becomes 40, and after that it will becomes 80. That means when you are reaching this capacity, it will increase automatically the size of the vector or an array list. Depends on the your creation of the list type. And another difference is, one difference is in size allocations, another difference is in accessing. Array list can be fast, vector can be slow. And another difference is, vector is thread safe. Why we are calling it thread safe means, because why it is as a thread safe is, it is implemented by synchronized. Why we use synchronized? In the thread safe means, suppose 2 or more threads try to allow this vector at a movement, it will not allow it. By default, it will not allow it. Suppose on the array list of the third element, I am performing by using the 3 threads one operation. At a time, only one thread can be perform the operation. It will block the 2 other threads. In the vector, it will be happen like that. But in the array list, it will not happen like that. Vector is the old one, array list is the new one. That is the main difference is synchronization. Vector is a thread safe, array list is not thread safe. Why vector is a thread safe? It is implemented by the synchronized keyword, so it is a thread safe. Okay. Now, this array list and vector can be stored the elements in a continuous memory location like an array, but the difference is it will be with a dynamic size. Okay. Now we are going to the linked list. Linked list, what it will do is, normally it will store the elements, right, in the continuous memory location. That means suppose this location is at 100, it will be at 101 or 104, depends on the size of the element occupied. Then when compared with the linked list what it will do is, it will randomly store the element. Suppose my 10 element is at 100 location, it will be store other element 30 is at 200 location, somewhere else. That means where it finds the space in a memory, there it will be stored in the form of nodes and maintaining the links to them. How can I tell you this? Suppose consider it is one memory. In the memory unit, normally your array can be stored the elements in the way of 10, 20, 30 in a continuous memory locations. For a while, linked list how it will be stored. Suppose 10 is at here, then other element is at somewhere 20, and here somewhere. Okay. Okay. Suppose it is the first element, it is the second element. Suppose I have another element of 30, it is at somewhere location, but it will maintain the links between them. How it will maintain the links is, normally this element can be created as a node. Normally it will be implemented by the double-ended queue. Okay. That means what it will do is, it is the element actual value and it will store the address of the next element. It will store the address of the next element. Suppose it is also one node. Suppose this is at the 100th location, it is at 200 location. This 200 value can be stored in here. Okay. And next, suppose it is at the 300 location, then this 300 is stored in the node 2. Okay. And what it is this previous node store is, it will store the previous node address. That means it will store the 100. That means from at the current node you can access through the previous and you can access the next. Okay. Like this way it will maintain the address and maintains the order of insertion, maintains the order of elements. That means suppose first 10 will be inserted, then 10, 20, 30, like this it will maintain the order. Okay. In a same way the linked list performs the scenario. That is the major difference between the array list and the linked list. Linked list stores the elements in a random locations, not in a continuous location. Okay. It is the major difference comes to that linked list, and the methods will be the same, somewhat same. Okay. Suppose how can you perform addition? That means adding an element into the list. You are using the add, right? Here also you can use the add, and you can use the add all, right? Here also you can use the add all, and some more methods you can use the add is add first, add last. That means these two methods it will not in the array list, it will be in the linked list. What it will do is, add first means it will add the element at first. Add last means it specifically add the element at last. Okay. Normally it will add the element at last. Okay. Then fine. In the same way, to remove an element, remove a collection of elements, remove all, right? And suppose you want to update the set, here also the set, and suppose you want to know the size of the list, then size is the method the same. The concept of storing of the elements is the difference, but all will be the same, remaining all will be the same. Suppose we'll run a program, right? I can include a main method and I can create a list. How can you create a linked list is, in a same way of the array list, you can use by list interface, you can create. Suppose I am intent to store only the strings, then string, okay, list, okay, list is the name, suppose new linked list. Import the linked list. Okay. Suppose if you check where this linked list can be from is, linked list is the method. Okay, linked list is the constructor. Normally here it is a constructor, right? Here we are using in a constructor. We are calling it as a default constructor normally, because you are creating an object for that class. And suppose if you observe here, it is the linked list class. It will implement by list. If you observe, linked list extends abstraction and implement by the list, dequeue and clonable Java is serializable. That means it will be from the list interface, and you can implement the dequeue also. We can see that in the queue interface concept. Normally you have to be understand here is, it will be coming from the linked list is coming from list interface. The same way, this is one way of creation. You can create, suppose list 1, and another way you can create by using here only the linked list string list 2. This is the data type. You can mention anything, linked list of. Okay, normally it is up to you. You can mention the data type here also or not. You can mention here also, it will be the same, but what you mention here, that is only you have to be mentioned here. Okay, we are calling it as a generics. The open, that means less than and greater than symbols, is calling as a generic normally. This is the two ways you can create the list. Okay, how can you perform the addition operations is, list1 dot add. You can use the add, suppose 1, list1 dot add of 2, right? Sorry, we are storing the strings, right? So hello and Ram. Suppose you want to print that is out of list 1. The same, what the ways we can perform in the array list, those all can be, you can perform here, but the difference is the storing way. The storing way is only the difference. It will maintain the insertion order. That means first you are inserting the hello, so it will be stored at the first index, and second you are storing the RAM. And you have to be understand the things. List maintains the insertion order. List interface, all the things can maintain the insertion orders. Insertion order is nothing but, suppose I am try to add the RAM as a first one, then RAM should be the first inserted element and hello is the next inserted element. But here I am performing or adding the hello to the list 1 first. So my RAM should be lies in that list 1 after the hello only. Why? Because I am adding this element after this. That means that is, you are calling it as an order. Insertion order will be maintained in the linked list. Okay. Actually, entire list interface will be maintained. In the array list also maintained, in the vectors also maintained, in the linked list also maintained, in the stacks also maintained. Okay. So this is the way. And suppose if you want to add into the list 2 dot add all. Okay. List 2 dot add all of list 2. Sorry. And list 1. Okay. This add all is nothing but, suppose you want to insert all the list 2, that means all collection of elements you have to be add at a one time, then it will be adding to that. Then you can print here the list 2. The same it will be print, right? What it will print before. Okay. Suppose if here I can add the list 2 dot add of Sita. Okay, list 2 dot add of Sita. That means now the list 1 elements inserted after the Sita text. That means Sita should be comes from in the list 2. After that only this list 1 can be adding. Why? Because in the list 2 this theta variable or the theta value comes first, right? So it has to be comes first in that list axis also. If you observe theta, after only your list 1 elements will become. But if you observe in the addle, what it will be do? It will not store in the form of a list in a list. What it was storing? Normally, if you are storing the list 1 in another list, how it has to be stored? It has to be stored like Ram hello, suppose like this. Normally it has to be stored like this, but in the add-all you are adding the collection of elements. That means what it will do is every element in this list can be inserted into the that list 2, not as a list, as a single individual element adding into that list. That will your add-all can be performed. In the same way, you can use the add first. Suppose in place of add-all I can use the add first. Now it will change the order. Okay, now it will throw an error. Why? Because add first accepts only one element, but you are inserting the collection, right? So that is the purpose. Suppose you want to insert at a particular index, then what can you do? Suppose I want to insert at the 0th index, you can mention it as a 0. It is the index, right? If you want to insert at a particular location, then you can use the index. What it do? Hello and Ram at the starting. Why? Because I am using the index of 0, so it will comes first, right? In the same approach, suppose you want to add the, this is at add last, already you have in the last, right? Then the scenario list 2 dot add last, you can always, it will be add last, right? Suppose you are using the add, so add first I can do add Hanuman. Okay. Now it will be add the at first location. It will do adding at a first location, not at the last. If you are using the add last, it will be added at the last. Okay, these are the two things. And suppose you want to remove, then you can use the remove and the index. Suppose you want to remove, right? Remove. Okay, but if you observe, this one is not in the list, right? If I run this, what it will be happening is nothing will be happen. Why? Because the element is not exist, so it will not remove that. Suppose if the element is exist, it will remove that element. If not exist, then it will not remove. And removal means if you can add the collection and the set is the same size. Suppose the way of travels is also the same. In the array list I will explain that, right? How many ways you can travel into that how many ways you can travel into the traverse into the list, right? One way by using the indexes. Here also you can use the get. Suppose you want to access one element, list 2 dot get of 0. Okay, get is the method. In the get you can pass the index value. In the get you can pass the index value. Based on that index value, it will be return the value which can be lies in that. Normally here the index means node 0, node 1, node 2, like that. Node 0, node 1, node 2, like that. That means that is the way it will be stored the things. Fine. Now we already tell that, right? How many ways you can traverse? One way for int I equals to 0, I less than list 2 dot size. Okay, you can perform list 2 dot size and I plus plus. You can access, right? Sys out of a list 2 dot get of I. That means normally way of approach like an arrays you can traverse, and another way for string, right? String ele colon list 2 by using for in loop. We are calling this for in loop. Now the element means ELE means actual element, so you can just print the ELE. And another way by using iterator. Suppose iterator it equals to already use it, right? List2 dot iterator. That means depends on the variable name you can use and use the iterator. This is the one way. You can traverse in a forward direction. Suppose while it dot has next operation, what it will do, it will check the next element exists in that or not. Okay, and you can print the sys out of it dot next. The same, these approaches you are already followed in the array list concept. Those all can be you can follow in the linked list also. What you can follow in the array list, those all can be followed in the entire the thing. But you have to be understand the thing is the difference of the storing of an elements. Normally both will doing the same operations, but what will be the addition to that is it will be stored in the form of a nodes in a dynamic memory location. That means random memory location. Okay, so compared to the array list, it will be not at all. That means it will be depends. Suppose when you are dealing with the real world scenarios, which list type you can prefer is it will be depends on the scenario. Suppose the case is you have to be access the elements fastly. That means suppose you want to access the element fast, then array list is preferable. Why? Because in the array list you can access the elements by the indexes. So array list can be better than the linked list. Suppose you have the frequent insertion and deletion operations, then linked list is perfect to you. That means depends on the scenario you can use that. Okay, this is the linked list. Normally linked list is like an array list, but the difference is in the way of storing. In the form of nodes, it will be store the things in a same approach. In the same approach, suppose next we can discuss the stack, right? Stack, what it will do is normally stack follows the principle of philo. Philo is nothing but first in last out, or else last in first out. Both will be the same. Vice versa, last in first out. Normally how it will be happening is suppose when you are dealing with the notepad, suppose this is a notepad, right? When I am dealing with the notepad, you are doing the Control Z and Control Y, right? These are the operations of the stack. Control Z, what it will do is it will undo the operation. Control Y what it will do is రెండోది operation. Normally suppose if I press the control Z, what it will do? It will comes to here, right? If again I will press the control Z, then it will be comes to the back. If I press the control Y, that means rendo, it will be comes to the again first. That means it when you can access by using the stack performations. Stack is simply like a one logic of implementation. The logic of implementation is you have to follow the principle of what will be enter the first into the stack, it has to become last. It has to become last. Okay, and you can explain that, right? Normally, suppose consider it is like a stack. Stack is also one like a list, but the thing is one end is closed, one end is closed. Suppose I am storing the elements 10, 20, 30. Suppose I am storing the elements in the order of 10, 1, 2 and 3. I am storing the elements in the order of this way. Okay, so I am inserting the element into the stack here. That means 10 will be stored here, and 1 upon the 10, and 2 upon the 1, and 3 upon the 2, and 20 upon the 3. Normally here you have to follow, so the 10 has to become last. Suppose you want to delete the 10, what you have to do is first you have to remove the 20 and 3 and 2 and 1 and remove the 10 and again insert the things. Only one way is open to you. Like suppose normally telling the real world examples, like in a library the books are there, right? In a tub of books, the books already placed in the tub, then you can pull out the last book, you have to pull the all, then only you can pull it, right? In a track of plates also can be placed in the track like the tub, then you can pull in the same way, pull out from the same way. This is the principle, it has to be followed. And now you have to be understand some terminology. We are calling this one as a peak, top element as a peak. Peak is nothing but the top element in a stack. Peak is the top element in a stack. This is one thing. And suppose there are some conditions, peak and empty stack. Suppose your stack is empty, how can you check it? Then normally here you can get that error. Suppose normally when we are implementing normal data structures, there are the two cases, stack underflow and the stack overflow. The conditions are, suppose you are fixing the stack size. Suppose I am fixing the stack size of 5. Okay, I am fixing the stack size of 5, but I am trying to inserting the 6. Then I am trying to inserting the 6. Then it will goes under the stack overflow. That means you have the capacity of only 5. You are inserting to the 6th. Here not the case will be possible. Why? Because here it will be a dynamic size. It will automatically increase the size when you are inserting. But here the possible of stack underflow. Stack underflow is nothing. But suppose your stack is empty, but you are trying to remove the element, then it is the case of stack underflow. Let's show that. And you have to understand the terminology. The terminologies are, some operations are there. Normally, how can you add an elements in the array list? By using the add, right? Here you can use the push. Push means you want to add an element to the stack, and pop. Pop is for removing an element from the stack, and peek. Peek is to find the top element in the stack, and size to know the size of an stack, and you can check is empty. Is empty is the method, check your stack is empty or not. Only these 5 operations you can perform on the stack. Only these 5. comparing to the array list and other things. Only these 5 you can perform. Okay, we can implement that, right? Stack is also from the normally I can show that stack is inherited from the vector actually. So stack is also thread safe, and what are the methods vector contains, all can be contained by the stack also. I can create a class day, sorry, stack. Okay, stack implementation. In the stack implementation main, okay, in the main I have to create a stack, right? You can create stack by using the list interface. Suppose list, I am intent to only the store the integers. Okay, list equals to new stack. Fine. This is the way you can implement the stack, or else you can place the stack here itself. Both will be the fine. Suppose you can place the stack here, everything will be the fine. Okay, but capital S. Here I am using the small s, if you observe, right? Okay, this is the one way, and another way is you can use the stack, and also you can place it here, or else you can place it in the here. Also you can mention the type of the data you are intended to store. Suppose you want to push the data, simply I can take it as a st, right? st dot push operation. What it will do is it will stores the or push the element into the stack. What is the problem? I am also pushing the integers only. Wait a minute. What is the issue? I think it is issue with the compiler. Why? Because I am storing the only integers. It is again converting to the integers, right? So I'll do one thing. For a while I can go with the strings. Maybe it is a compiler type of issue. So push off hello. For a while right. Normally it will take the list interface type, right? List interface have no method, so I can go with the stack hello, and suppose this stack, where this stack will become is stack actions from the vector. Your vector is also comes from the list interface. List is comes from the collection is from the iterable. So stack is action from the vector. So vector, all the methods can be applicable to your stack also. That means what are the size and what are the add methods are there, those all can be applicable to that. So that is the scenario. So hello is one element to the add, right? st dot push of round, fine. st dot push of round. Suppose if I print that stack, then it will print like a list only. it will print like a list only. Suppose if I check the peak element st dot peak, okay, then it will returns the top element. Top element is ram, that means what is the last inserted, that is the top element, so it will prints the ram, right? Suppose you want to know the size, then stack dot size, it will print the size of your stack, that means how many elements in your stack. 2 elements, right? And another method is pop, right? Suppose you want to delete an element, then pop. By default it will delete the top element, that means it will delete the ram, it will delete the ram. Why? Because ram is the peak element, right? So it will delete the ram. Next, suppose here I can pass, I think index, no, pop. That means how it will do is, it will be simply performs on the thing like insertion order can be in the way first that it will maintain the insertion order, but when comes to the deletion, what is the last inserted, it will be deleted first. Okay, 5 operations here. The important thing is, suppose here also I can perform one more operation is, you can check the is empty, that means your stack is empty or not. You can check your stack is empty or not, right? False, it will return true or false, Boolean operation. Suppose the same operation I can perform for the now it will throws the error here. The error is empty stack exception. Empty stack exception. Why? Because here I have my stack contains only 2 elements. I am deleting these 2 elements. So now my stack becomes empty. So in the empty I am trying to perform the pop operation. Suppose if you observe stack empty operation here, then it will return the true. Stack is empty, true, right? This is the operations. Suppose I think some more operations, I think st dot. If you observe in the stack, you can perform with the add all, and add element also you can use, capacity, clear, clone. These all are the methods of vector. These all are the methods of vector. These vector methods also you can applicable on the stack, but stack has to be follow the principle of philo, first in last out. That means what has to be inserted the element is into the first, it has to be come out also the first. Okay, but in the list interface, what you have to be remember is, the thing is the difference between the array and a vector, that means array list and the vector, and the difference between the array list and vector with the linked list, and also stack. You have to be understand the types. Why? Because the methods all are the same for the one method to the other. Why? Because all can be inherited from the one type of list interface, right? So all the methods will be the same and all the traverses also will be the same. But you have to understand the difference between the types of the list. And right, this is the list interface, all about the list interface. And we are left with the topics of set interface, map, and another thing as a queue. These 3 we are left with. Set and queue we can cover in the next session, right? And map we can take it as a one session particular. Normally you have to understand the difference between the list and the set and map and queue. The issue is, suppose we have the one type of data structures or the data storing elements, then why we are go with the other is, we have some what we are considered as a loophole in that. We have to rectify that. We can choose the another thing. Normally in the loophole of the list is, list can accept the storing of duplicates, right? List is capable to storing the duplicate elements also. Suppose it can able to store one double time, one triple time, that means it will allow the duplicates. Now comes to the set, it will be override that operation. In the sets, You can't able to store the duplicate elements. Set only stores the unique element. Suppose one element exists already in the set, you are trying to add the same element, it will not store that. And another thing, list can store or maintains the order, right? Insertion order. But set not maintains the insertion order. That means it will store the elements in a random manner, not in the insertion way, how you can insert it. And comes to the map. Maps is like a, suppose you are aware about the JSON objects. JSON objects stores the as the key value pairs, right? Like that map also stores. Suppose you are familiar with the Python programming. In the Python you have a dictionary, right? The same way dictionary how it will perform. In Java map also perform the same thing in the way of a key value pairs. And comes to the queue. Stack, how it will perform the stack? Stack performs in the way of first in last out. This is the implementation of first in first out. First in first out. That means normally in the queue you are observing in a temple or in a ticket counters, anything, they are following the queue, right? That means who enter into the queue first, he has to become out from the queue also the first. The same way of it has to be follow the queue. In the queue also we have the some more types: priority queue, double-ended queue, and black red queue, I think. Red black queue, something. These are the things we have to be left. We can cover up these three concepts in 2 sessions. That means by Thursday. Okay? Fine. Thank you.